Hello, I'm Evan Wallace, president of Applied Fizzics. In this video, we're going to find out exactly what happens inside a can of beer when you shake it, and investigate the urban myth that tapping on the can keeps it from foaming. Let's get started. I've got a can of Rainier here, an old college favorite. I'm going to shake it 10 times and open it. No surprises here. Quite a mess. Now I'm going to try a second can of Rainier, shake it hard 10 times, and then tap it with a spoon 10 times when I'm done. Let's see if this makes any difference. Whoa. Well, I think we can call this myth busted. But it's a fair question to ask, what exactly is going on inside the can? To answer this, I built a pressure cap with a gauge on top of it that can screw onto a plastic soda bottle. Using this, we can pour a beer into a clear bottle, put the pressure cap on, and pressurize the bottle. That way, we'll be able to see exactly what is going on during the shaking and read the pressure in the beer at the same time. The idea here is that we will pressurize the beer to a typical beer-like pressure around 35 pounds per square inch, put it in the refrigerator overnight, and let it come to its equilibrium pressure. Then we're going to shake it and watch the gauge. If the shaking releases extra CO2 from solution and thus increases the pressure inside the beer, that would explain the spewing upon opening. Okay, now the beer has been poured in the bottle and we're going to pressurize it. We'll pressurize it to 35 to 40 pounds per square inch and take it off to the fridge. The pressure may rise or fall a little bit overnight, but it will eventually settle down to a stable value. Okay, off to the fridge we go. And we're back about 24 hours later. And look at the gauge. It's reading about 36 psi. And now the fun part. Let's shake it up and see what the beer does and what the gauge says. Well, look at that. If anything, the pressure dropped by 1 or 2 psi. So I think we can safely say that shaking at equilibrium does not release any extra CO2 into solution. So that cannot be the cause of the spewing. But I think you'll notice one thing. There's quite a bit of foam in the bottle. And that foam is just from the mechanical agitation of the shaking. And when the cap is removed and the headspace pressure escapes, each one of those little bubbles is no longer compressed by the headspace pressure and expands rapidly. And that's what causes the whole body of the liquid to bloom and exceed the capacity of the container. Now, I just want to make one further point here, that foam does not equal pressure in any way. Here I have a very, very flat beer. It's been open in the refrigerator for a couple of days, and I'm going to pour it into our pressure bottle. I'm going to put the cap on, just as I did before, and I'm going to shake it up, and we're still going to get the same amount of bubbles, even though we are at, as you can see on the gauge, at 0 psi. I've not pressurized the container. So I give it a good shake. I get the same amount of foam, and of course the gauge is still at 0 psi because it wasn't pressurized. So foam does not equal pressure. So now we have, I think, a real answer to our question. It's the expansion of the foam due to the release of the headspace pressure that causes the spewing. But one more question. What if we pressurize this flat beer? What happens then? We'll save that for next time. Thanks for watching.